Okay, today we're going to go ahead and talk about how to construct confidence intervals. Before I talk about how to construct what's called a confidence interval, let's talk about what that even means. So, when it comes to statistics, you have something called a point estimator. The point estimator is the type of statistic that provides an estimate for the population parameter, or the type of statistic that was used in the sample. So, the type of statistics we use are means or proportions. The point estimate itself is the value of that statistic, so the actual mean or the actual proportion. Once you have your point estimate, you go ahead and construct, in statistics we construct what are called confidence intervals. And confidence intervals give us the plausible values for a parameter. Remember, a parameter comes from the actual population, not just from the sample. We calculate this interval by taking the point estimate and then adding or subtracting some margin of error to that. So here's an example where they constructed a confidence interval. So this group went ahead and did a survey of 1,014 adults, and they created a 95% confidence interval that said between 9% and 15% of all Americans expect to spend more money on gifts this year than last year. So in this case, the point estimator that was used is not as obvious as it is in other cases, but in this one, the point estimator is a proportion. The reason I can tell it's a proportion is because my confidence interval, which is between 9% and 15%, is made up of percentages. You can't change at mean, if the point estimator was a mean, you can't convert that to a percentage. But if it's a proportion, you can convert those numbers to percentages. So that's how I knew it was a proportion. The point estimate is the value. Remember, we find this interval by taking the point estimate and adding or subtracting the margin of error. So the point estimate in a confidence interval is always the very middle value. So I can find that middle value by adding the 9% and the 15% together, and then dividing by 2. And so I'm finding the average, right? The exact middle. So you get that it's 12% for our point estimate. Then the margin of error is what we're adding or subtracting to build this confidence interval. So I just need to find the distance of this point estimate from the 9% and from the 15%. And it doesn't matter which one you do it from, because remember, it's right in the middle. So if I take 15 minus that 12, I find that my margin of error is 3%, meaning I added or subtracted 3% to the 12% to get the 9 to 15%. Let's do a couple more of those. So the next one, we have a nationwide poll of 2,525 adults that estimated with 95% confidence that the proportion, so they use the word proportion, of Americans who support healthcare reform is 0.7638 to 0.7962. So the estimator in this problem would be proportion because they told us that. It was in the wording. The point estimate, remember, we're taking this interval and we're finding the exact middle. So to find the point estimate, I'm going to take 0.7638, add it to 0.7962, and divide that by 2. And if you add those together, divide by 2, you will get 0.78. And then we're going to go ahead and find the margin of error. I'll find that margin of error by just subtracting that point estimate from either end. So if I do 0.7962 minus 0.78, we get a margin of error of 0.0162, because that's our distance between either one. Let's do one more, and then Then we're going to actually build our own confidence intervals. So this next one gave us a confidence interval for the mean score, meaning since it said mean, this is a point. Our point estimator is a mean. So the mean score on the NAEP test is between 200 and 360. So the point estimate, once again, is directly in the middle. So I will add those two together. Divide by 2. And that will give me a score of 280. So 280 is our point estimate. And then the margin of error is the distance. So if I take 360 minus 280, I get a distance of 80. Just remember that you don't have to, I always took the higher number and subtracted the point estimate from the higher number. It won't matter if you take the point estimate and then subtract the lower number from that. You'll still also get the 80. And that's because the point estimate is directly in the middle. So at this point, we're going to go ahead and calculate our own confidence intervals. In order to calculate our own confidence intervals, we have to have something called a critical value. You're going to notice that on these previous examples, I kept saying with 95% confidence. You can actually change your confidence by changing what your critical value is that you use in your formula. So if I want a 99% confidence interval, I use a critical value of 2.576 and so on. So for proportion, our formula is right here. I'm going to zoom in on that a little bit. So we call this first little variable the p hat. When you have that little mark above, it's called a hat. That value is your sample proportion. So you start out by taking your sample proportion, which makes sense because that should be your point estimate. Then you take the z-star. Remember, the z-star is our critical value, so it's our chart right above us. That's where we get that. And then we do the square root of the p hat again, so the sample proportion, and then 1 minus p hat. And then we divide by n. N is your sample size. So that is the information you would need in order to create your own confidence interval for a proportion. Now for a mean, it's kind of similar, but because we're working with means, we don't start with a proportion. We start with so we use a different variable, x bar, and that x bar is representing our sample mean. So when you have that little line above, we read that as x bar. Once again, you'll see you add or subtract, and then we have the critical value next, where we use the chart, and that's just based on what percentage we want for our confidence interval. And then we take our sigma. Sigma is our standard deviation, and we divide that by the square root of n, which n still represents our sample size. So those are your two equations. And you use, obviously, one equation if you're dealing with a situation with proportions, and then the other one when you're dealing with situations with means. So the rest of this video will be all about doing examples for each one of these.